Okay, so hi everybody. So today I'm going to talk about PG Anonymize, which is a new extension for transparent anonymization on Postgres. But the main topic of the conference is actually to present a bit of Postgres infrastructure to extensibility to add your own code running inside Postgres, and a bit of information on how it works and what is query workflow on Postgres. Okay, so my name is Julien Rouhaud. So I've been working with Postgres since 2008. I'm a major contributor. So I've been working as a developer and a DBA. So I'm also the author of HypoPG, Powa, and some other tools. And now I'm working at Nile, which is a company that's doing Postgres for SAS, serverless Postgres. So today's agenda. So first, I will quickly introduce what is PG Anonymize and what is scope and what is supposed to be solving, what problem is supposed to be solving. The main part, which will be the second part, which is actually how it's working under the hood. And the last part, if I have enough time, is a bit of example usage on how you can set it up and see like the anonymization working. So first, a bit of introduction in case you're not familiar with it. So what is anonymization? So it's the goal of anonymization is to remove or modify or degrade like a personal identifiable information, or PII, which is something something very popular to do recently, especially in Europe and US. And the idea for that is that once you anonymize the information, you can't use it to identify one individual in particular, but you can still use the data one way or another. So as an example, if you can identify someone by his birth date, you can actually truncate the date like the year of the birth year of the birth decade. And when you do that, you can still do some statistics, say, oh, like people from 18 years old to 25 years old, you can do some statistic, but that's not enough information to identify someone. So that's what anonymization is supposed to be used for. So PG Anonymize is an extension, and the goal is to provide a way to perform the anonymization automatically, transparently. And the scope is only that. It only provides you the infrastructure to anonymize the data, but it doesn't provide you like a function to say, like, how do you anonymize a name, a credit card number, or birthday, or anything. You have a lot of library to do that. So I recommend the Python Fucker library, but you have a lot of other stuff, and you can just use them as a SQL function or PG Python function. We will see that in the last part. So the goals I had when I was working on this extension is mostly to be safe and robust. So a user that is actually anonymized shouldn't have any way to escape the anonymization and see the real data. The DBA is supposed to set up things, and whatever you do, you have no way to see the real data. It's also supposed to be transparent. So you have nothing to do to see the anonymized data, and any tools you actually be working with will honestly anonymize data. So it's working with PG dump, with PG sample, or any tool that connects to Postgres. And there are no limitation. The only limitation I actually put explicitly is to ensure read-only, because in my opinion, doing some writes when you see anonymized data is a good recipe for failure, because if you're going to modify data when you don't have the original one, it's probably a bad idea. So now let's see how the extension works. So the general idea is to intercept the query that is happening on the backend automatically. So for instance, you do like a select star from person, and the extension will rewrite the query automatically and transform it to something that injects the anonymization. So here, for this very simple extension, very simple example, the extension will rewrite the query with select star from with a subquery. And this is actually the query that will do the anonymization. So here, I'm just doing a naive example or anonymization of a phone number, which I just keep like the phone code, which is actually Taiwan phone code, and XXX for all the number. So you know where the person is living, but you don't know the actual phone number. So if you execute that instead of that, you see the data anonymized, and there is no way you can actually access the original data. So let's see how you can do that with Postgres. So one thing you need to know for Postgres is one very convenient way as a developer to execute your custom code is to use what Postgres call hooks, which is actually like a point in the query execution and other part of Postgres, where Postgres will actually execute the code you give to him on top or in place of the regular code. So when you load your module, you just declare the list of hooks you want to use. And then when Postgres does some action, for example, executing a query or something, if your hook is registered, it will call it and do what you want it to do. So the only difficulty here is to find a suitable hook to do the query writing I was talking about. Yeah. So here's a query workflow. So that's not the whole truth, but it's very, very close to the reality. So as a client side, what you do is like a select star from your anonymized table. Everything else is happening on the backend side. So first you have the parser, which will parse your raw SQL statement and produce 1 or 0 or multiple structure called a raw query. This raw query, for each of them, it will go through the parse analysis stage and output one query per raw query. This will then go to the rewriter, which is what we use when you have a view or rules on any of your table. And once again, outside of the rewriter, we'll get one or multiple query, which is the same kind of object. And then for each of those query, you will go through the planner. And the planner will give you like one plan per query. And the plan is what will the executor will actually execute to get your data, or whatever was your query. So we will focus here on the parse analysis, which is what happens right outside of the parser. So it transforms a raw query into a full query. And it contains all the information you need to fully identify all the objects you have in your query. So for instance, if you do a select star, it will transform the star into like a select phone number, name, full name, everything. It will check all the data type you are using. It will check like the phone number is a text or things like that. So you have all the information you need to fully know the query. And at the end of the parse analyze stage, it will call a hook, which is called the post-parse analyze hook. And that's one hook we can use for PG anonymize to transform the query and inject anonymization on the fly. So for all the point-in code I'm talking about in this talk, I show a quick example and the file where it's actually defined. So if you're interested, you can look a bit more into it. So you have a lot of functions used for the parse analysis. One of them is a parse analyze fixed params. That's when you have like a fixed number of parameters. So you get your raw statement as an input input data, and also the original query text and a bunch of other parameters that are not really relevant here. So here you see it called transform top level statement, which is like transform a select or a delete or update or anything into a query, does a lot of other stuff, and eventually call the post-parse analyze hook using like the parse state, the query, and the jumbled set. The jumbled set is what's used for pgstat statement to check the normalized query and generate a normalized query string. And then he returns the query after you possibly modify it in the post-parse analyze hook. So now what's exactly inside a query? So it's defined in a parse_nodes.h. So it's a simple ST structure that contains all the information that the planner will need to create the plan. So it has a lot of fields, so a lot. So you have, for instance, the select part of a select statement. You have all the columns. You have the qualifiers, which is like the where clauses, the join clauses, and you will also have, which is interesting for us, the list of tables, which is stored in the R table field. So you see here the query structure. So you have a command type. So for instance, for a select, and you have a list, which is used to be a linked list in Postgres and is now an array, R table, which is the list of range table entry, which are basically the tables. So let's look at the range table entry. It's yet another struct, C struct. So what's interesting here to see is it defines not a table, but a relation. So in SQL, a relation is like a set of rows. It could be like a plain table. But if you join two tables, it's actually a join relation. It's also a set of rows. And in our case, a subquery is also a relation. So we have our range table entry, which can be a plain table, so RT relation. And you can probably see where I'm coming from. For is what we basically have to do is transform a relation into a subquery inside the query structure, and we can actually inject the anonymization on the fly automatically. And here you can see that. So the list, there are a lot of fields in this structure, and the fields that are used for is different for each RTE kind. But you can see that for a subquery, we have a subquery field, and it's also a query. So a query can contain another query, which for a subquery is a query that you actually be using. So to anonymize a relation, another thing you have to know about the relation is that in the query structure, you don't store, for instance, like the table name or the field name or anything. You actually only store offset and object identifier. So when you have a column, say when you select phone number from person, the query will not contain phone number. It will contain the field number 1 of the relation something. And a relation, you don't store the relation itself, but you store an offset in the range table, in the list of range table. So it can be like the colon 1 of the relation 2. So that's important because if we actually change the RT from a query to a subquery, it won't break anything here because as long as you output the same number of fields with the same data type, it doesn't matter if the query change itself, it will still be like the colon 1 of the RT2. So it will still work the same, and it will just see new data. So all we have to do is change the normal relation to a subquery that does the anonymization. So how can we do that? So the idea is, as I mentioned in the first slide, is to generate a subquery to do all that. So we generate the subquery by looking at the original table, loop through all the columns, and generate a select field 1, field 2, field 3, and replace field 3 with any expression that outputs the anonymization, depending on how you configure it. So we'll see that a bit later, but it's using a security label. And yeah, I also added compatibility for inherited and partition table. So if you anonymize a root partition table and you select from one of the partition, you will inherit automatically the anonymization from the root level. So you don't have to do that for every single partition. So PG anonymize, that's a short extract of the code. So first, I just get all the security label, which is a list of, for each column, what the expression you want to use, if any, to anonymize the data. So I just start by outputting like a select, and then I just loop for all the attribute numbers, which is like column 1, column 2, column 3 of the relation. If I found something, if I found a security label, I just use the expression, which is a security label, as, and I use the exact same identifier. That's not exactly required, but it's easier to debug. And if I don't have a security label, I just output the original column. And then I just finish using like from the original table name. So when this stage is done, I have something, a query text, which is the subquery I want to use inside the original query. So once we have that, we just need to do exactly what Postgres was already doing, which is passing this query, calling the parse analysis to get the query structure and use it, replace it with what was already done. So obviously, when we call the parser, the parse analysis, we don't want to call again pg-anonymize. We don't want to anonymize data. So there's a flag say, am I calling inside pg-anonymize? And in that case, I just don't recursively do it and explode. So, so once I have this query, so I do the parser, which is a query parser, parse analysis, which is parse analysis fixed params, because I don't have any parameter here. And so that's how I do it in the extension. So here, I assume I have the SQL statements that have been built before. So I just call pgparse query. I get the first node. So it returns a list of query. So since I know what I generated, I know that I only have one query, so I just get it. I call the parse analysis. And I have my subquery, and I just hack the RTE and say, oh, now it's not a RTE query, it's a subquery. And the subquery is this field. So in reality, there are a bit more code, but we clean up things a bit, but that's basically it. I use a subquery here. I say it's a subquery. And when it's done, my work is finished now. I say, okay, now I injected the subquery with the anonymization. I just say return, Postgres, keep doing your job. So Postgres will plan it, execute it, and the user will see the anonymized data without having done anything specifically for it. So it's all transparent, and there's nothing the user can do to escape it. And since everything is working with a column number and RT offset, nothing will break because we still refer to the third column of the RT2 and so on. So it's actually very safe. So all of that is working well for all DML and DQL statements, so select, update, and everything. Now, if you do like a copy, for example, if you use a pgdump, this is not going through the same schema I showed you with the parse analysis and everything. It will be bypassed because for a copy, you don't need to actually generate a query or everything. So it goes through another thing called process utility. And fortunately, there's also a hook available there. So it's process utility hook. So I can just use exactly the same technique. So if you see a copy something to, which is like exporting your data, or copy a query to, I just do exactly the same thing. And instead, I generate on the fly a copy with your anonymized query to. And this way, any utility statement will see anonymized data. So pgdump will dump anonymized data. Okay. So now it may be a bit abstract for now. So I have some slide to see how it's actually working, how you configure it. So hopefully it will make it more real. So it's using, as I mentioned before, a declarative approach using a security label. So security label is a feature in Postgres where we can attach a random string, whatever you want, on an object. So for pg-anonymize, we use two kinds of objects. We use the column, and we use a column to attach any expression that we want to use to emit anonymization. And we also use the role. And this way you can say which role is supposed to be anonymized and which is not anonymized. So this way, you just have, if you connect as an anonymized role, you will see anonymized data, and that's it. You can't escape it. And so the security label is also entirely done by your custom model. So it needs to be loaded to use it. You can't declare a security label for a module that does not exist. So this one is important. You need to make sure that the extension is loaded first. So the basic step to do that is make sure pg-anonymize is loaded. This one is do the early configuration. So you declare your anonymization rules using security label. So basically it's just expression. You declare which roles you want to see that are using anonymized data. And then you configure the role to load automatically the extension. We can load it for everyone. If the extension is loaded and your role is not anonymized, it will do nothing, but it will call an extra hook, which is never good for performance, but it won't do anything apart from that. So the first step is to make sure pg-anonymize is loaded. So in this case, I use a load command because it's very convenient. So it requires super user privilege, but that's only for the initial setup. And if you want to use security label, you also need to be super user anyway. So when it's loaded, you can declare a security label for the pg-anonymize extension. So you just declare your rules. So here, this is the rule I've been using since the beginning of the talk. So this is like this is a utility statement. So security label is actually a utility statement. And so the syntax is security label for, so that's your module. So in my case, it's pg-anonymize on what you want to use it. So in my case, it's a column. It's person.phone number. And I say now I want to output this. So I output a hard-coded plus 886. Which is very bad as anonymized. It's assume everyone is Taiwanese, which is hopefully not the case, but that's just for a very simple example to show it's actually outputting something different than the original data. A recommendation is to use dollar quoting, which is $$. This way you can use a single quote inside, so it's easier than putting like triple or multiple quote everywhere, so easier to use. And extra security measure is make sure you return the exact same type, because the parse analysis will check that when you do like a select phone number, it will know it's actually a text. So if you want to change your extension and now the expression is returning like integer, everything will break, because now it will say, it will try to emit a number as an integer or the opposite way, and usually it will not work. So you have to make sure you use the exact data type. So here you see I'm explicitly casting my expression to text, even though it's actually already a text. If you don't, pg-anonymize will check it for you and raise an error if it's not the expected data type. So once you need to do that for every single column of every single relation you want to anonymize. So when it's done, you go to the next stage, which is declaring a specific user as anonymized. So it's also a security label. And you just say now, like on roll Alice, and now it's anonymized. And now every connection open after that with the Alice role will only see anonymized data. And the final step is to modify a session preload library so that it's done automatically. So you now do alter role and you set session preload library equal anonymize and other if you want. And now Alice will automatically be anonymized, but she doesn't ask for it. When she connects, you as a DBA decide that she will see anonymized data. And also be careful, it's something that is done when your connection is open. So if Alice already have open connection, the old connection will still see the original data. So you can kill all the existing connection if you want to make sure that she only see the anonymized data for security. And now if you just use it, so I actually use the exact command I showed before. And now if I connect with the user Postgres, and I do like select star from public.person, I see Jendo with like a random phone number. And now if I connect as Alice and I execute the same query, I get the anonymized data instead without doing anything apart from connecting as an anonymized role. So it will work with any client, any library, any tool, dynamic SQL, pgdump, So the same, if Alice is doing like a stored function that is actually calling SQL, she will also always see the anonymized data. So that's the main goal of the extension, to be very, very safe and guarantee that the user only sees the anonymized data. So what is sorry, already handled in the extension? So all the general infrastructure I showed you is already stable and working as expected. Inheritance is handled with like a partition table and inherited table. And with also the possibility to overload something on a partition itself if you want to have different anonymization on different partition table. A lot of sanity checks. So I mentioned it makes sure you have the correct data type. It makes sure that your anonymization expression doesn't try to inject data. So you can do that when you pass the expression. If it's written 1 parse 3, you know it's only one query. If it's written multiple parse 3, you know there is an injection, so you can't use it. And it makes sure it's read-only. The next things I'm planning to add to the extension, so a lot more of sanity check, including runtime sanity check, because you don't, if you do like an alter table and change the data type, you don't want the anonymization to break your everything. So it has to be done at runtime too. Make every rule actually a bit more thorough to check everything. And also handle rules and view, which are not fully handled for now, because it's done in the post-parse analyze hook, which doesn't see what is done after the rewriter. So for this one, we just need to do it at the planner hook instead of the post-parse analyze hook, but other than that, it's the same. And so if you're interested in the extension, you have the link here, and my contacts are here. So if you have any question about the extension or extensibility in Postgres, I will be happy to answer. Thank you very much.